Okay, today we are going to talk about factoring special cases. These right here on your note sheet are the formulas that we used to multiply special cases. And what factoring does is it undoes our multiplication. So instead of on the first set of notes that we did before our last test, these appeared first equaling these. Now we're going to be looking at polynomials that are exactly like these cases here. And then we're going to unmultiply them to where we get an answer that looks like this. So let's look at our first one and let's try to figure out which one this is, which case this follows. So we get x squared minus 8x plus 16. We have a negative sign and then a plus sign, and there's three terms. So a negative sign, plus sign, three terms. It's going to be in this format right here. It's going to be a minus b squared. It's going to be in this format. Now what we have to do is figure out what a and b are. Well, to do that, what we have to do is take a square root, because this right here, a squared equals x squared. So then what that means, because this right here is a, this right here is a. If a squared equals x squared, then if we take the square root, a is going to be x. We don't worry about this middle term on these. We don't even care what that middle term is. To get our a, we take the square root of the first thing. To get b, we take the square root of the second. So we could even write this down. For a, square root of the first. And to get b, we take the square root of the last. First and last. So that's how we get our a and our b. So our b then, for our last one, we take the square root of 16. So to get b, we take square root of 16. So b is 4. Once you get your a and your b, it's a matter of just plugging it right into the formula. So this answer would be x minus 4 squared. And the way to recognize a special case is you will have perfect squares in your first position and your last position. In these cases, you don't really care about the middle. You just look at the first and the third. If the first and third are perfect squares, then you know it's going to fall into one of these formulas. So x squared, any variable squared is a perfect square. And then you should know your perfect squares. If you need to write them out, you can write them out. The perfect squares are 1, because that's 1 times 1. 2 times 2 is 4. That's another perfect square. 3 times 3 is 9. 16, 25, 36. We could go on and on and on. Okay, these are all examples of perfect squares. So since 16 is a perfect square, we knew we could do this. And that's how you're going to recognize your special cases. Because I won't on a test go right out and tell you which ones are special cases. You have to know, okay? So let's look at B. We look at our first term and our last term. We look to see if they're perfect squares. 4 is a perfect square. T squared is a perfect square. 81 is also a perfect square. So to get a, we take the square root of 4t squared. Now in order to do that, we take square root of 4, which is 2. Square root of t squared is t, so this becomes 2t. So a is 2t. B, we take the square root of the last term, which is 81, which is 9. So we have our a and our b. We also need to look, it's a trinomial where both of these are positive, so we're going to use this top formula where they're both positive up here. So it's going to be a plus b squared. So our answer for this then is 2t plus 9 squared. So a lot of this is recognizing your perfect squares. Letter C. We have 9g squared minus 12g plus 4. We have a minus and a plus in this one, and there's 3 terms. So the only one that fits is this middle one, minus, plus. So then what we do is we want to find a. So a is going to be the square root of your first term, 9g squared, which gives you 3g. B is going to be square root of 4, which is 2. Then if we look up here at this middle one, it's going to come into the form a minus 2 or a minus b squared. So then that's going to be 3g minus 2 squared. So the hardest part about this, guys, is figuring out which formula to use. And then also perfect squares. You have to recognize perfect squares. Now, if you look at letter D, here's the thing with D. On D, 45 is not a perfect square. 20 is not a perfect square. However, I want you to look at the numbers. We have 45, we have 60, and we have 20. Each of those numbers has a greatest common factor that we could pull out like we did on the board yesterday. 45, 60, and 25 is going to be a factor on all of these. So we can take out a 5. This is 5 times 9, 5 times 12, and then this was 5 times 4. So we can take a 5 out of this problem. So if we take a 5 out, we're going to have left 9x squared, because this 5 is gone, minus this 5 is gone, 12xy, plus this 5 is gone, 4y squared. We're not going to forget about this 5, though. It is still a factor of this polynomial, but we're going to come back to it later. Now we're going to look at this. If you look, 9x squared, that's a perfect square. 4y squared is a perfect square. So we have an a and a b. This is in the format where we have a minus, a plus, 3 terms, so we're going to use this formula right here. So a is the square root of 9x squared, which gives you 3x. B is the square root of 4y squared, which gives you 2y. Now we can plug it into our formula, a minus b squared. So we get 3x minus 2y squared. And then we have to put this 5 back out front, because it's still a factor of the problem. So if you have to factor something common out at the beginning, make sure you put it back at the end. And these are all the ones where we have a trinomial. The only difference is some of these have a minus in them, which would mean you use the middle formula. Some of them are both plus, like B, they were both plus, so we use the top formula. Now we're going to look at situations that are like this. Difference of squares is what we call this. A difference of squares. So each of these, if you have a square root in the first and the last one, same rules as we wrote way up here, then we can do the formula a plus b, a minus b. So those are the formulas. So here we're going to look at the first one. Square root a is going to be square root of x, which is, or square root of x squared, which is x. B is going to be the square root of 64, and we get 8. So a is x, b is 8. We're going to use the formula a plus b, a minus b. So we get x plus 8 and x minus 8. That is our factored form. The second group is typically the easier group of problems to do. Looking at letter B, to get a, we want the square root of 25x squared. And to find b, we want the square root of 64. Square root of 25x squared is going to be 5x. B, square root of 64 is 8, and then we plug it into the formula, 5x plus 8, 5x minus 8. Basically, you use your a and b, but in one of them you make a plus, one of them you make a minus. And that's our answer. So the difference in these and the other ones are these are only binomials. There's only 2 terms. These have 3. That's the difference in the 2. Okay, letter C. Now, if you look here, letter C, 10 and 40 are both, they're not perfect squares. Neither one of those are perfect squares. However, if we look at this 10 and 40, we can take a common factor out of both. If you look at this, 10 is a factor on each of these. That makes that 10 times 1, and this one is 10 times 4. So in each of these, we're taking out a 10. So we're going to do just like we did on the example up here, where we had to take a 5 out. Right here, we had to take a 5 out. Here, we have to take a 10 out. If we take a 10 out of the 10 times 1 factor, we're just left with 1. So we have 1x squared minus 4. Now, 1x squared and 4 are both perfect squares, so now we can find our a and our b. Our a is the square root of 1x squared. B is the square root of 4. So on top, we just have x. You can write a 1x if it makes you feel better. Square root of 1 is 1. Square root of x squared is x. And then this is 2. So then our factors, you can't forget about the 10. The 10 has to come into play. So 10 is a factor. And then we have x plus 2 and x minus 2. Because again, it's still a binomial, so we're still using this last formula right there. All right, let's look at this last one, letter D. Letter D, 8 and 50. Neither one of those are perfect squares, so that means there's probably a common factor we can pull out of here. We're looking at 8 and 50. Looks like a common factor is going to be probably 2. Yeah, it's going to be 2. Because this is 2 and 4, and this is 2 and 25. So we're going to take out a 2. If we take out a 2, we're left with 4y squared minus 25. And then if you recognize 4 and 25 are each of those are perfect squares, so now we can find our a and our b. Our a equals square root of 4y squared. Our b is the square root of 25. So on top we have 2y. For b we have 5. And then we cannot forget about this factor of 2 that's sitting out over here. So then our factors are 2, parentheses, 2y plus 5, 2y minus 5. And that is how you factor your special cases. Thank you for listening.